In classical mechanics, impulse is the product of a force, F, and the time, t, for which it acts. The impulse of a force acting for a given time interval is equal to the change in linear momentum produced over that interval. Impulse is a vector quantity since it is the result of integrating force, a vector quantity, over time. The SI unit of impulse is the Newton's second or, in base units, the kilogram meter per second. A resultant force causes acceleration and a change in the velocity of the body for as long as it acts. A resultant force applied over a longer time therefore produces a bigger change in linear momentum than the same force applied briefly. The change in momentum is equal to the product of the average force and duration. Conversely, a small force applied for a long time produces the same change in momentum the same impulse as a larger force applied briefly. The impulse is the integral of the resultant force with respect to time. Mathematical derivation: in the case of an object of constant mass, impulse J produced from time t1 to t2 is defined to be where F is the resultant force applied from t1 to t2. From Newton's second law, force is related to momentum p by. Therefore, where Ip is the change in linear momentum from time t1 to t2. This is often called the impulse momentum theorem. As a result, an impulse may also be regarded as the change in momentum of an object to which a resultant force is applied. The impulse may be expressed in a simpler form and the mass is constant. Where F is the resultant force applied, T1 and T2 are times when the impulse begins and ends, respectively, m is the mass of the object, v2 is the final velocity of the object at the end of the time interval, and v1 is the initial velocity of the object when the time interval begins. The term impulse is also used to refer to a fast-acting force or impact. This type of impulse is often idealized so that the change in momentum produced by the force happens with no change in time. This sort of change is a step change, and is not physically possible. However, this is a useful model for computing the effects of ideal collisions. Impulse has the same units and dimensions as momentum. Variable mass: the application of Newton's second law for variable mass leads to the Tchaikovsky rocket equation. See also, specific impulse. Wave-particle duality defines the impulse of a wave collision. The preservation of momentum in the collision is then called phase matching. Applications include Compton effect, nonlinear optics, acousto-optic modulator, electron Phonon scattering. Notes. Bibliography: Searway, Raymond A. Jewett, John W. Physics for Scientists and Engineers. Brooks Cole. ISBN A0-534-40842-7 Tipler, Paul. Physics for Scientists and Engineers, Mechanics, Oscillations and Waves, Thermodynamics. W. H. Freeman. ISBN A0-7167-0809-4A. External links: Dynamics.